Hey guys, welcome. We're going to do our homework for 7-3. Now remember to upload your notes and do your lesson check. And this is your homework assignment. Okay, so we're going to do questions 11 through 27 and skip around a little bit. So number 11 says, for each triangle, name the triangle similar to ABC. Okay, name it and explain why. So we notice it looks like this one has a scale factor of 1.5 because it looks like they just multiplied 1.5 times each number. So I'm going to assume this one's my small one, right? So I'll order the sides. I don't know which one's least to greatest, but I'll just order them X, Y, and Z. And now I'll order these. So 1.5X, 1.5Y, 1.5Z. And set these equal. Now, if they equal the same decimal, we will be good. So notice X divided by X is 1, Y divided by Y is 1. So we end up getting the same fraction. So this is going to have to be equal. Right? So that spells side, side, side. So yes, this is similar because of side, side, side similarity. But we also have to name our sides. Okay, so AB has the X on it, so we gotta, that one corresponds. And then BC has the Y on it. So this would be the one that corresponds because that one has the Y on it. So if we say triangle ABC, similar to this other triangle, we gotta go in the same order. ABC across the X and then the one with the Y, so that would be NLM. Nice. Now, looking at the next one, would these be similar? And we notice they have one angle that matches and a second angle that matches. So because angle T is equal to angle A, because they both have one arc mark, and we know angle, what is angle B here, right? Angle S is equal to angle B because they both have two arc marks. Then, yeah, that only leaves us the last angle, angle C, and the last angle, angle R. So we just have to make sure we order these in the same order, right? Triangle ABC is similar to triangle TSR because of angle similarity. Cool. Question 13, error. What did Russell do wrong? Okay, so one triangle has 60, one angle, and this triangle has 80, which is a different angle. So right now it looks like he's what I call planting evidence. He's pretending that the 60 is over here somewhere, but we don't have any evidence. So this would say not similar, because there's just not enough information. All right, 16, 17, and 18 are like our example in our notes. So we notice they give us 3 sides and 3 sides here. So we'll order the sides least to greatest just to make sure we're writing them in corresponding patterns and order these least to greatest. 5.4, then 9, 11.25. So turning these into decimals, we get, and the decimal actually keeps going. I don't think that's going to work out because, yeah, 6 divided by 9 is, those are not equal to each other. So we're going to say no, not similar. And it says explain, and so the reason why is because they are not the same ratio. They are a different ratio. All right. Anytime from back before the midterm, right? Anytime you have 2 angles, you can solve for this missing one, right? And subtract the other one. I get 80, so this angle is 80. And then I'll do the same over here. So 180 minus one of the angles minus the other angle. All right, so that angle is 40. Ooh, sorry. Somehow my hand. Okay, so this is 40. And yeah, that looks similar. So I have angle L is equal to angle R because they're both 40 degrees. That's a piece of angle evidence. And we also notice angle J is equal to angle P because they're both equal to 60 degrees. And that's enough to say, yes, angle similarity. Now 16. We have 3 sides here, but only 2 sides. So that we can't use side, side, side. We have one angle here and one angle there. Oh, but we have 2 angles, so we can solve for this third angle. All right, so this is 108. And that's actually helpful, right? This angle matches, this angle matches. So I can actually take 2 of the sides and use the side angle side similarity theorem to see if these equal the same ratio. So when I do side angle side, I'm going to ignore this third side. It's not really playing a part in there. And then also notice I don't even know that side, so I can't use it. Okay, so the angles are definitely the same. Let's order the sides least to greatest. So in this triangle, I have 3 and 6. And this one I have 4 and 8. That's looking good. 0.75 is equal to 0.75. So my evidence would spell 2 sides. And I also have an angle that is included that is equal, because angle T is equal to angle Y because they're both equal to 108 degrees. So it's going to be yes, side angle side similarity. Cool. All right. 20. What is X? Okay, so we can use the fact that the sides make the same ratio if we can prove they're similar. So let's start with that. So I know 2 of the angles. All right, so that's 67. Yep, this is looking good. 67, 67, so that'd be 46. Yep, okay. So they're definitely similar because of angle similarity. So now that means their sides make the same ratio. So see this angle 67. Okay, so I can order those least to greatest. And we can make sure that the shortest side corresponds here. So the shortest side, and then one of these sides, right? So we can cross multiply to solve. So the first wing here is 20 times x, and the other wing is 26 times 26. And we always double check for reasonableness. So with 33.8, so 20 and 26 is a little bit bigger. 26 and 33.8 is a little bit bigger. We like it. Nice. All right. And then on the next page, they asked us to do 22 and 23. So looking at the building manager, they need to replace the 9 panes. Hopefully you see these 9 panes here. And they're all the same size. So we also notice that they're similar to the big one. So we have a big triangle, the mommy, and all these little 9 babies that fit inside the mom. You might be like, well, how do you know they're similar? Well, we pretty much know they have to be, right? Because look at the side length. This is, the mom is 3 times bigger, whatever this is. That one's 3 times bigger. And whatever the width is, this width is 3 of those, 3 equal pieces of those. So it's definitely similar. Because we can map one on top of the other. And that one's just 3 times bigger using dilation. So now when we look at this, it says the mom is 96 here and the mom is 42 here. And so that would mean if they were similar. So let's figure out this other angle. I think it's 42, but let's just be sure here. Yeah, 42. So that would mean this. Oh, I made this baby too small. I can't even draw in there. So make it a little bit bigger. Same angle, 42, 42, 96. So one of the questions here is what angles would the pane be cut? So the angles are cut at 42, 42, 96. All right, that's one part of our answer. Another part asks, what are the dimensions of each pane? Okay, so if the mom is 60 and 40.5, then this was cut in 3 equal pieces. So we just want to divide by 3 and divide by 3. So 60 divided by 3 would be 20. And I guess I got to do that in my calculator. 40.5 divided by 3. 13.5. So the dimensions are 20 on the bottom, 13.5 on each side. 23. A survey device's screen is 0.26 meters wide, and so I have a triangle, 0.0026, and then the width of that is 0.026, and the height of that triangle is 0.1. Now, if the surveyor wants an image, and this is exactly how this works on similar triangles, we know those two angles are equal, and we know these two triangles make the same ratio because this side's equal, that side's equal, and this would be parallel to the ground. So you see this huge Z, this angle wouldn't equal that angle, and this angle would equal that angle. So we end up knowing that this is going to create the same type of ratios. All right, so they want us to calculate D, and the width of the big triangle is 2 meters. So we can set this up in a ratio. The width of the little triangle at top, 0.0026, and the height of the triangle, and it should make the same ratio with the width of the big triangle and the height of the big triangle. Now we'll just cross multiply to solve. So solving this, and that makes sense. It's hovering up in the air in order to be able to see that dimension. Okay. Last group of 3. Yep, let's finish this off. So 25 says, what would be sufficient? Meaning right now it might not be enough. Okay, so I have 2 angles. So let's figure out the third one here. So I get 36. And we have sides that look like they make the same ratio, right? This is 3 times 2, and this is 5 times 2, right? So if they gave me another piece of information, like if this last piece was whatever this side is, times 2 is 9. So working backwards, what's 9 divided by 2? I get 4.5. Yeah, that's why I like this one. If this is 4.5, then 4.5 times 2 is 9. And this one would spell side, side, side congruent. So if they gave me that third side, it would be, or excuse me, side, side, side similarity. They would be similar because of side, side, side. So what else would get me there? All right, starting over. what if Q is 63? If Q is 63, we have A is 63. Okay, that's nice. And do these two sides make the same ratio? Yeah, they make that same ratio. 3, 5, 6, 10. That's the same ratio. And the angle fits in between. So we like that one. Side, because it has side angle, side similarity. What if angle P was 81? Okay, if angle P, wait a minute. If angle P was 81, P is in the middle and B is not, like that matches with C. So that's going to be bad. What if R is 63? So we have A is 63. So we need Q to be 63. So that won't work. And we know this one doesn't work because we need RP to be 4. That would make a different ratio. And we need them all to be the same ratio. Nice. All right, 26. For what value of FJ would make this triangle? So let's FGJ, FGJ. This little one, I'm going to make it a little bit bigger so I can write on it. Would make that triangle similar to this triangle. I'm going to make that one bigger. All right. FHG. So this is 18, and notice they both share F. So they're saying, what would this need to be? So we have to put X. And we all also know that this would be X plus a 27. Okay. So we can set this up, but actually pretty good. So this is my small side, right? And this is my long side, and I have a matching angle in between, so that's fine. This is my small side, and this is my long side, and I have a matching angle in between. So I can set up for, I'm going to try for side angle side similarity. So ordering these sides least to greatest, the small side and the long side, and this one ordering this one least to greatest, small side and long side. All right, now we're going to cross multiply to solve. So we have 18 times 18 and x times x plus 27. Interesting. Let's crunch these numbers. X squared and 27x. Okay, so this feels like algebra class, right? I got to get all of my units on one side and factor this. This one's getting a little crazy. A little interesting question here. Okay, so I need to factor this. And let's see, I can just just look for an app. Quadratic Calculator. Okay, so we have A, B, and C. So we have A is 1, and B we have is 27, and C we have is, what did we write? Negative 325. Let's go back. Let's double check that. X 27 and negative 324. Okay, negative 324. So let's see what we get. Okay, so we get either positive 9 or negative 36. All right, so we either get positive 9 or negative 36. And that, I'm sorry, we get, so we get positive 9 or negative 36. So that's not going to work, right? So this would look like x minus 9, x plus 36. And we end up getting these answers, right? We can't have that because we can't have a length be negative. So we just kind of toss that out. That's called the extraneous. Nice. Okay, so we get our answer of 9. Now that seems a little crazy. You could have also done this by plugging it in. So my small one is 9. Could have plugged that in. This is 9 and that's 18. Notice those are double. And so 9 here, 27 and 9 would give me 36 and 18. Notice these would make perfect. Yep, those make a perfect same ratio there. This is 0.5 and that is 0.5. So we really like our answer number 9. Okay, 27. Oh, this is a big one. Let's take a look. It says my altitude here is 3.5. This distance, we're going to call D. The distance, this is my mountain, right? This distance is 2.4. So taking a look at that, I'm just going to redraw my triangles here, right? The horizontal distance is 2.4. If the height of the mountain is 2.8, what is the horizontal distance D? Okay, so I have my big triangle. I've got my horizontal distance D. I know that's a right angle, right? And there we go. Now my smaller triangle, I know this is 2.8. And we know these sides make the same ratio because the angle from the ground. So this works because of angle similarity. And it's exactly how we use radar to figure out our distances from objects. So let's see, this distance here, let's play around with this a little bit. If the distance was 5 kilometers, then this distance would be 5 minus this 2.4, right? That's how I'd figure that out. But I don't know that it's 5. It's just D. So this has to be D minus 2.4. Okay, now we can figure this out. So we can order the sides, least to greatest. D minus 2.4. And order the sides, least to greatest. And cross multiply to solve. So this side I get 2.8D. And then 3.5 times D minus 2.4. So let's distribute this, right? So 3.5D minus 2.4 times 3.5. Okay, so I get 8.4. All right, so I'm going to subtract 2.8D from both sides. .7D. And then I'll add, wait, wasn't that supposed to be 8.4? Let me double check that. Yeah, 8.4. So add 8.4 on both sides. Okay, so I get 8.4 is equal to 0.7D. Nice, I end up getting a regular old number. That's 12. So what is the distance? We got the distance is 12. Now it says the ground speed or the horizontal speed of the helicopter is 1.6 kilometers. Okay. When will the helicopter reach the campsite? All right. So if we look in the picture, here's the helicopter. When will he reach? And we know his ground speed. Okay. So we know this distance is 12, right? And his ground speed is that. So we're going to need our answer in minutes. Okay, so we just know, do I have to multiply or divide that? And if I take my 12 kilometers, I actually want kilometers to cancel. So I know that I'm going to divide this rate because it's equal to 1.6 kilometers for every 1 minute. I knew to divide because I need kilometers to cancel and I may answer to end up in minutes. Okay, so 12 divided by 1.6. Beautiful. So you get there in 7.5 minutes. Not a super long helicopter ride. Last part, the radio at the campsite can only be transmitted for a distance of 5 kilometers. Okay, so here's my campsite, and so this is 5 kilometers, and this is still my helicopter, right? So when my helicopter gets 5 kilometers away, that's when he'll be able to get the signal. If the helicopter begins immediately to descend toward the campsite along the diagonal line, so he was here and he got to this point, he'll be able to get our signal. Is that kind of making sense? How far will the pirate be horizontally when he contacts it? So they're asking for this, right? Well, we know that this is similar to this other triangle we have. So we have our bigger triangle. This is 3.5, and this is 12, right? And so we can just order these sides least to greatest, right? So we have X, and we have our 5 kilometers. And so I need this, but I need that. It's like, oh, no. But notice I have a right triangle, so I can use Pythagorean theorem to solve for that, right? C squared. So let's solve for that. We get 3.5 times 3.5. Right, and they add 12 times 12. Get 156.25. So if I take the square root of both sides, I get 12.5. Okay, nice, and that number makes sense. So I'm ready. I have those two numbers. So I have 12 and 12.5. So we can cross multiply to solve. Whoop. There we go. So 12.5 times x is one of the wings, and 12 times 5 is the other. So let's take 60, divide by 12.5, and we get 4.8. So that's the horizontal distance from the radio, from the campsite, where you'll be able to hear the radio on the helicopter. Check you next.